this video, we shall be solving this question, and the question said, an electron has a velocity of 6.0 times 10 power 6 meter per second in the positive x direction at the points where the magnetic field has the component this. Then we are asked, what is the magnitude of acceleration of the electron at this point? We have to keep in mind of some things. We're given velocity, but we're told that it's actually at the direction of x-axis. Then for the magnetic field, we are given magnetic field to be this as well, and we are asked to calculate the acceleration. Let's write down our parameters. We're given v to be equal to 6.0 times 10 power 6 meters per second. So, but we are not forgetting the x, which is, let's use I to indicate the direction in the x-axis, and the magnetic field is equal to 3I plus 1.5J plus 2K, indicating the directions. Okay, and we are asked to find the acceleration. Acceleration is unknown. So for us to find acceleration, we should know that if we're able to get the force in this whole system, then we can use this formula F equal to ma, where we were told that this is electron. Okay. So, but for us to determine the value of F, we should know that F is equal to Q V cross B. So, but since it's electron, then the charge should be the charge of electron. We have that the Q will be equal to 1.6 times 10 power minus 19 column. This should be Tesla. So let's solve. Let's solve for Q. Solving for Q, we have F to be equal to Q is 1.6 times 10 to power minus 19 into the V was only given to be 6.0 times 10 power 6 I cross the magnetic field would be 3I plus 1.5 J plus 2K. To simplify this, we have to first of all do the cross product of this. So working on the cross product, we have that V cross B is equal to the determinant of I, J, and K I, J, and K. So the component of V in direction of I is 6.0 times 10 power 6, and the component in J is 0, and that of K is 0. Then the component of the magnetic field in I direction is 3, and in J direction is 1.5, and K direction is 2. So let's simplify. If you don't know how to solve the matrix and determinant, you can go back and check our previous video on that. So I believe it will be a better guide, because I'm not really going to like explain it explicitly. So V cross B will be equal to this, then that should be 0 multiplied by 2 minus 0 multiplied by 1.5 I minus J into 6.0 multiplied by 10 to the power 6 or multiplied by 2 minus this 0 multiplied by 3. So for the K components, we have okay, let me put down the K. For the K, I have 6.0 multiplied by 10 to the power 6, or then should be multiplied by 1.5 minus this is 0 multiplied by 3. So let's try to do it individually. Then I have this the first term is for the I component. I have this to be 0 multiplied by 2 minus 0 multiplied by 1.5, and this should be equal to 0. Everything here is 0. Then for the J component, I have 6.0 times 10 power 6 multiplied by 2 minus 0 multiplied by 2. So this 0 multiplied by 3, this will be 0, but this will be equal to 6.0 times 10 power, or it should be 12 rather. It should be 12. Times 10 power 6. So the K component will be 6.0 times 10 power multiplied by 10 to power 6 multiplied by 1.5 minus 0 multiplied by 3. This part will be 0, and this will be equal to 6.0 multiplied by 1.5 will be 9, 10 to the power 6. So we've gotten the I component, we've gotten the J component and the K component. Let's substitute back to this our equation, or this very one. So we only succeeded getting this the terms in the bracket. So we have Q to be 1.6 times 10 power minus 19. So we can say that F is equal to 1.6 times 10 power minus 19, then into the I component here is 0I plus 12 times 10 power 6j plus 9 times 10 power 6k. So let's change the color and solve. Let's open the bracket. F is equal to this multiplied by I should be 0. I think we are missing a minus sign somewhere. Yes. So we forgot the minus sign over here. So this should be minus 12. Minus 12. Then this is a negative sign. So we have this expression now. 1.6 times 10 power minus 19 multiplied by this will be equal to 1.9. (1.92) times 10 power minus 12. J, and 1.6 times 10 power minus 19. When you multiply this, we'll be having, this will be negative. Then we'll be having 1.44 times 10 to the power 12, negative 12k. So for us to find the net force now, F net will be equal to the square root of the component of X. So this is the force in both X and the K component. So for us to find the net force, we can say that Fj rather, square plus Fk square. So if we do this to find our net force, then we'll be having this, the net force is equal to the square root of minus 1.92 times 10 power minus 12 square plus 1.44 times 10 power minus 12 square. So, and if you take the square of this, we'll be having the square root of the square of this is 3.6864 times 10 power minus 24 plus the square of this is 2.0736 times 10 to the power minus 24. So if I add it up, I'll be having 5.76 times 10 to the power minus 24. So the square root of this expression will be 2.4. times 10 to power minus 12. So we've gotten force, and we're asked to calculate the acceleration. So to calculate the acceleration, we have F is equal to ma. And from the question, we were told that it's electron. So the m should be the mass of electron. The mass of electron would be an m(e), which is mass of electron, which is 9.11 times 10 to power minus 31. So, and we've gotten the force to be this, the net force. So we can say that A is equal to F divided by M, which is equal to 2.4 times 10 raised to power minus 12 divided by 9.11 times 10 raised to power minus 31. And if you use your calculator to compute this, then the answer will be equal to 2.6 times 10 raised to power 18 meters per second. So this is the final answer. Let's go back to the option and see if our solution is correct. So going back to the option, we can affirm that the option C, which is 2.6 times 10 power 18, is the right answer.